Any case, all right. We are going to proceed. We may be joined by the NIH director. If not, he'll just watch it on YouTube. I'm going to ask Dr. Shirley Tilghman to please join me on stage. Thank you.
You're welcome.
For coming. So when I was planning the 2019 Symposium and Great Ceremony, I really wanted to include, as you heard in my introduction to Sid, I wanted to include a guest who would help us reminisce in celebrating the 30th anniversary of NHGRI. And in particular, for this slot, I wanted to identify someone of historic significance for genomics and for NHGRI. I want someone who's been a friend of the Institute since the beginning, someone who's a stellar scientist and an accomplished professional, and most important, someone who would be kind enough to say yes to my invitation to come here today. We're fortunate that Shirley Tilghman checks all of those boxes and is generous enough to be joining us here today. So immediately, I want to thank you. And I will also say that I really did have a lot of fun preparing for this, a fireside chat without the fire, as always. And I knew quite a bit about your amazing career, but I took the time to surf the web and learn more. And if you do a Google image search, my goodness, there's a lot of pictures of you. You look like you have so much fun for so many years. So that's the one thing I'd say. And here is just a sampling of the kinds of pictures that you immediately see. Now, in terms of some biographical details, Shirley has long and distinguished career as a mammalian developmental geneticist, for many years studying how genes are organized in the genome and regulated during early development. Your path to a research career began in Toronto, Canada, where she was born. She later attended Queen's University in Kingston, Ontario, and then came to the US and got a PhD from Temple University. And then she came here to NIH as a postdoctoral fellow, and I'm going to have a question about that. But then she initially assumed a faculty position at the University of Pennsylvania, but after that moved to Princeton University in 1986. 2 years later, so now we're at about 1988, she became an investigator in the Howard Hughes Medical Institute. And 10 years later, she became the founding director of Princeton's multidisciplinary Lewis Stigler Institute for Integrative Genomics. Throughout that time, she published prolifically and trained, this becomes important, trained a small army of outstanding students and postdocs, including some that we know well. For those who don't know, people that came through Shirley's lab. We've tried to dig up some photos here. So this is not when she was in the lab, but a more recent picture. Tara Wolfsberg was an undergraduate, if I understand it right, working in your laboratory, and has kept in contact with you since. And, but the other individual associated with your laboratory as a postdoctoral fellow is, and this, we did get some photos dug up, although they're not in great quality, as this guy, Bill Paven. He looks really different now than then. You know, on the other hand, he also had a photo of you, and you look pretty much the same. So, you know, with Richard Hodes here, I mean, you know, there's no aging in you or even you. But you know, Bill Paven, a long distinguished senior investigator in our intramural research program, when he came out of your lab, you know, he looked like this, you know, sort of very Tom Selleck-like. Yes. You know, nice mustache, lot of hair, yeah. You know, and then, you know, 25 years later, look what we did to him. Sort of looks like Dr. Evil from an Austin Powers movie or something. So you took better care of him than we did. That's my conclusion. Well, in 2001, after being on the Princeton faculty for 15 years, Shirley became the 19th president of Princeton University, a position she then held until 2013. And from all the reading that I have done and from what I have heard, Shirley was and is beloved at Princeton University. In fact, in my most recent visit there, is it a road or is it a path named after you? Tell me about that.
It's called Tillman Walk because it goes by all the buildings that were built during my time as president, just to remind me what I'm responsible for.
No, that's okay. Oh yeah, but to have even a walk named after you. Yes, no, so. Needless to say, your contributions as a researcher, a scientific leader, and of course, Princeton's president were simply remarkable, and I know has been greatly appreciated by the Princeton community. Of course, you continue to be an active faculty member today, and needless to say, you've been given many, many honors, actually far too many to list, and I'd embarrass you if I dare try to list them all. It also includes an amazing list of honorary degrees, and this one in particular caught my interest because I found out that Washington University, my alma mater, gave you an honorary doctorate of science degree in 2007, and that same photo with the same chancellor 11 years later, it was me in that place. And I was honored to get that award, but when I learned that you had gotten an honorary doctorate, it made that word even more special because of that, now that I know that we share something. To share anything with you, Shirley, is a great honor. The other thing I really wanted to point out, you know, you agreed to come give this, and so, but earlier this fall, I just happened to bumped up against something that made me realize what a role model. I always knew you were a role model, but there's something about when you become featured in fundamental biology teachings, that must mean a tremendous amount. And I came across this because my daughter is taking college biology classes now at the University of Virginia. This happens to be the textbook that she's using.
Malcolm Campbell.
Yep, and sure enough, when they came up against, just a few weeks ago, when they came up against the genetics section, the lead feature in the genetics section of this textbook is an interview by you. Did you not know that? Or you don't remember that? Oh, I actually brought you a copy in case you really, here's a copy of that.
Thank you.
Actually, if you read in the bottom, it's an interesting quote. I have to turn around and say, if you have a quote, you must have said, send in there, if you've ever seen the children's book, Little Bunny, following blah, 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 just think of the H19 gene. So there must be something related to you reading stories to your children or something, and you saw some analogy with your journey with understanding the H19 gene.
Indeed.
So, any case, I think the fact that you get featured in an undergraduate biology textbook and as the lead in genetics is just saying a tremendous amount. Now, what I've not mentioned so far, but is relevant for Shirley being here today, is that you have been a great champion for the field of genomics and for NHGRI as an organization. In fact, Shirley was absolutely on center stage when NHGRI became an organization for the first time. In 1989, when we were first created by the Office, as the Office of Human Genome Research. You were one of the founding members of our first advisory group established by NIH to help what was then the NCHGR. And then you then played a key role in helping us determine exactly how it was that we were going to lead the US's effort of the Human Genome Project. So the point is that she is a long-time friend of NHGRI's. I'll just deviate for a minute and just say at a personal level, I first got to know Shirley when I was a postdoctoral fellow in Maynard Olson's lab. I was told early on, directly by Maynard, that Shirley Tilghman was terrific and I should always pay attention to what she says. I always did, I always will. But seriously, on multiple occasions during my career, at important inflection points, I have sought Shirley's advice. She's always found time to chat with me and has always said important things to me. So I am personally grateful to you for your mentorship and your friendship. Now, before we get into the early days of genomics, what I want to do, and there's a number of things, and I do have some more slides I'll bring up. Maybe I just want to not miss the fact that you were a trainee here. So tell us a little bit about, you know, what years were you here, who did you work for, what building, et cetera, et cetera.
What wonderful years, I have to say. So I was here from 1975 to 1978 in Phil Leader's lab over in Building 6 for the Lab of Molecular Genetics. When I arrived, and I should probably tell the story of how I got into Phil's lab. He at the time was really, you know, one of the nation's, and still is in my view, one of the nation's great molecular biologists, and I had no reason to think he was going to accept me into his lab until he discovered that I was Canadian. And you could see, you know, his eyes lit up, and he said, "Oh, you can be a Fogarty Fellow." And I said, "Whatever it is, I'll be it. I don't care what it is." But he had one slot left that he could use a Fogarty Fellowship. So I've always been grateful to the Fogarty and to the NIH. And so just to give you a very brief sense of what it was like, I arrived here And within 2 or 3 months, I thought that this was the biggest sandbox I'd ever been invited to play in. There wasn't anything I wanted to know that I couldn't find here about biology on this campus. I thought I'd died and gone to heaven until Phil showed me my bench, which was about this big. And I dutifully tried to work on it for about 6 months. And at the end of 6 months, I stormed into his office and said, Phil, I just can't continue to work on the bench this small. I need more space. And he looked at me as only Phil Leader can, for those of you who know Phil, and said, well, Shirley, it might help for you to know that your bench is about the same size as the bench that Martin Nuremberg solved the genetic code on. As you can imagine, I left his office and worked on my little bench for the rest of my time.
Who were some of the other postdoctoral fellows at the NIH around that time?
So the one who I interacted the very most with was John Seidman, who I was working on trying to develop the technology to clone the first mammalian gene, the beta globin gene. And he was really interested in the organization of immunoglobulin genes and was leading up to being able to clone both the germline versions of those genes and the rearranged in myeloma cells. The other person who was absolutely critical is a man named David Tiemeyer, who worked with me on developing the cloning technology and then went off and had a very successful career at Searle.
So let's fast forward a bit. So now I want to take you to the mid-1980s, when the notion of the field of genomics was first being discussed. Wasn't even coined until 1987 as a name. What were you, but by the mid-1980s and 86, 87, what were you doing in the lab then? And what was your memory about the first time you were even asked about the notion of mapping and sequencing the human genome?
So at the time, we were continuing to do work on how genes are regulated in early mouse development, and the model system that we had used to do this was the alpha-fetoprotein gene, which is expressed at very high levels in both the fetal liver and the yolk sac. In the course of studying that gene, we'd stumbled on this gene that you mentioned a few minutes ago, the H19 gene, which we may talk a little bit more about. But was a gene that we didn't understand. It was utterly mysterious, but it was regulated in a very similar way and by the same transacting loci as AFP, which is how we got interested in the first place. So I was, a hardcore mouse developmental biologist. And I think the first rumblings that I heard about the possibility of sequencing the genome really came out of Caltech and Bob Sinsheimer, who I think was one of the very first people to start talking about it. And I think he was motivated by the desire to find a new role for the biology labs at DOE Labs, which had basically run out of their reason to be. And he thought they needed a new high-tech project that they could embrace and make a difference on. So I think that was the first time I started hearing about it.
So that's when you started hearing about it. When did you start to get drawn into it? And when you got drawn into it, were you drawn in as an advocate or were you drawn in as a neutral thought leader?
I was drawn in as a person who has 2 X chromosomes. That's the
Well,
trick.
and to really bring this point home, this was one of the first important, or this was a key meeting, and there's a lot of Y chromosomes in that picture, right?
There are a lot of Y chromosomes.
Right.
But
is this the first time you were drawn in, or were you drawn in a little earlier than this?
No, this was late.
Yeah.
This actually,
Yeah.
so I got a call from Bruce Alberts asking if I would join a National Research Council committee that was going to look into the issue of whether to sequence the human genome. And I thought that sounded like a really interesting thing to do, so I said yes. But when I received the membership of the committee, it became crystal clear why I was on the committee, which it was full of people who had never sequenced DNA. And it turned out that I was the only person in the committee who had actually sequenced DNA with my own 2 hands. And that's because I was the youngest member of the committee by probably 10 to 15 years. And I think I was on it because they put the very distinguished group together and they said, oh my God, we need at least one woman. And I got the short stick. And that's how I got into genomics.
So they didn't even calculate your advocacy versus neutrality on the issue. This was purely about different.
I don't think they cared.
And so you started working on that advisory committee.
Yes.
And that marched along in the late 1980s.
For about 18 months.
Yeah. And is that all concluded before this Banbury meeting?
Yes, this Banbury. Francis, you were at this meeting, right?
Oh, he was. He's right there.
Yes,
So, by the way, for those who are sort of trying to imagine who all these various people are, and there are a bunch of here, let me just show you, because if you go, there's websites that you can see each of these people identified, and in particular, the people I highlight in yellow, you can see are either former directors of NHGRI or a former deputy director, or 2 former deputy directors as well. So NHGRI people prominently featured, but many other very impressive people as well. And this is one of these really iconic photos, because there weren't iPhones back then, so there's not as many photos.
Right.
So what are your memories of this meeting?
So my recollection, and Francis can correct me if I've got this wrong, is this was the group that assembled after the report was issued. So the report was issued, you know, its most important recommendation was that the federal government should launch a major project to sequence the human genome. We had, I would say, minimal recommendations about how that was actually going to happen. And so this group was pulled together to start putting meat on the bones and to actually get some of the, you know, literally, what do we need to do first, second, third, fourth, and so on.
Was it
Cold Spring Harbor.
Was it, yeah, Banbury, Cold Spring Harbor. Was there pretty good agreement, or was this one of these highly contentious Banbury meetings? Because Banbury meetings got the full spectrum. Do you remember?
My recollection is there was no one in this group who was opposed to sequencing the genome or opposed to launching a big project. I think to get into this meeting, you basically had to now be an advocate. But, you know, there were differences of opinion about how to go about it.
We're going to get to those in just a minute. And was Watson recruited yet as the head by this meeting, or unclear?
I can't remember.
Okay.
Do you remember, Francis, if he was identified by now?
So were you at all involved in the identification or the recruitment or any of the search that led to Watson being the first director?
I was not.
Just sort of happened, okay. And so then, you know, did you find yourself, by being on that key advisory committee or meetings like this, did you find yourself frequently in the crosshairs of debate in the scientific community that were churning?
Yes.
And if not, I'll remind you that you sort of were, but go ahead, I want to hear your answer first.
Yes, I was.
Okay, there you go. And I knew that because I sort of remember that. But I mean, back then I was a postdoctoral fellow at that point, and so I was digging out some more things that were relevant. I remember the nature of this article, but I don't remember the specific article. I don't know how you're going to react to it. But here's an article from 1989 written by Leslie Roberts. Interesting 2 pictures, prominently featured, Jim and you.
Yeah.
And it talked about, you know, all this controversy. And the real controversy was, this is when Watson was on board at this point and talking about how this wasn't going to be done by a bunch of small grants. This was going to be done by some big centers that were going to really focus. A big center controversy of 1989. And remember, the project was out of the gates within the year with big centers. So do you remember this article? Or do you remember the debate?
So no, I certainly remember the controversy. And you know, I think it relates to the nature of the criticism and the concerns within the scientific community that at the end of the day, I think proved unfounded. One was obviously, where was the money going to come from? The number that ended up in the report was $3 billion. In those days, that was real money. And there was a lot of concern within the scientific community that it was going to come out of my R01. So that was the first concern. The second concern is related to what you just said, which is biology has never been done the way physics is done. We are a cottage industry. The creativity of our work comes out of small laboratories doing investigator-initiated work, and we're going to spend a lot of money on boring science. So I think that was the second criticism.
Of course, that was my postdoctoral research project, but yeah, go ahead, keep going. I love that.
And so I think there was an image of large rooms full of robots, and then the final criticism, I think, was that we were going to generate all of these DNA sequences and we wouldn't be able to understand what they are telling us. And one of the revelatory moments for me was going over to talk to the physics department at Princeton, who had invited me over to explain all this to them. And I offered that as one of the criticisms of the community, and I could see that they were all frowning at me like, huh? And I said, well, why are you reacting this way? And they said, oh my God, that's all we do. We just generate data, and that's what gets us to start thinking about what they might be good for. Sky surveys. Yep. So that's when I sort of had that ha-ha-ha moment that it's possible that the data itself will be stimulatory.
Which it has been.
Which it has been, totally.
It's interesting because the thing you said just before then, when you were remembering quite accurately what your thinking was about that the centers weren't a comfortable concept for biomedical research at that time. You were, it seemed, enticed by them, but still weren't quite sure how they were going to be run and so forth. Sure enough, your memory's great, because the very last quote of this article is a quote by you, where you said, I still don't know, you opine, who will want to take on the job and do it, not just accurately, but with a little flair and creativity, which is actually interesting because one of the first funded centers was Francis's at the University of Michigan. One of the first funded centers was Washington University, where I was playing a major role. And these are the folks, I don't know if Francis and I did it with any flair or creativity, but we did take it on, and we were willing to take the challenge with it, including the criticism.
Yeah.
I mean, I remember, I'm not sure you remember, but I remember when I started interacting with you early on as a postdoctoral fellow, one of the things that I found was knocking me back on my heels a little bit was when I started interviewing for postdoctoral fellowships. I was already a postdoc, but I was applying for fellowships and going around and being interviewed. Some of the places I went and interviewed, they were saying, you're not going to really work on this human genome project. And then sure enough, when I started applying for junior faculty positions, they said, oh, it's really cute you're working on the human genome project. What are you going to really do when you have your own lab and your own program? Exactly. And I didn't get that from people like Francis, but I got it from some institutions. Sure. I remember you were among the people that said, do not listen to them. I mean, do not listen to them. And sure enough, I didn't listen to them.
But can I just make a separate point about how we ensured as a community that the work would be really creative and important for all of biology? And that was one of the recommendations that David Bostein and I worked really hard on the Alberts Committee, which is to ensure that the sequencing of model organisms were not only included in the project, but were going to be sort of the junior varsity of human genome sequencing, and was going to ensure that we had victories along the way. We could celebrate E. coli, then we celebrated yeast, then worms, then fruit flies. I think that was really important, but the other reason it was important is it attracted the best scientists in the country to the project, like yourself, right? Because suddenly it wasn't just about a bunch of human geneticists and some physicists and computer scientists. Everybody in biology was going to benefit.
Early on. And benefit
early. And benefit early on.
So was that mostly Botstein and you?
The two of us fought like a lot. That's one of the things I learned as a president. I'm not supposed to swear in public. But no, we fought to get that recommendation in there.
But Watson didn't resist that. I mean, because he's the one, of course, that went out and recruited Sulston and Waterston and folks and got some other models involved.
And I think Sidney Brenner was also very, very helpful. Sidney was on the committee, and obviously he, was very interested in having the worm done. But no, I think it was David and I who really, just wouldn't. We were dogs with a bone. We weren't going to let go. So
project gets out of the gates. Jim Watson is leading our efforts here. Were you on the very first advisory?
I was.
Were you on the advisory council when Jim left the NIH?
I was.
So then all of a sudden, anything you want to share about that, or just let it go?
You know what I would say in the beginning? I think Jim was essential. He was iconic. There wasn't a door on Capitol Hill that he couldn't get entree into. So knowing how important it was going to be, not just for the project, but for the whole scientific community to see that new money was coming in, I don't know that we could have had a better advocate at the beginning than Jim.
Yeah.
I think later, clearly Jim is not used to having a boss, and that became problematic. Yeah.
So then we had Michael Gottesman as acting director, and a search went on to find the next one. Were you at all involved in?
I was. I'm very proud to say I was on that search committee that persuaded Francis to leave Michigan and come to Washington.
So you were actually on the search committee.
I
And
was.
he took some arm twisting. Were you recruited to twist arms, or at least that's the folklore, was that there was a little bit of arm twisting, but you don't remember that part?
I think Francis did not need to be inspired. I think he saw this as a grand challenge, and I've never known Francis to shy away from grand challenges.
Absolutely true. So reflecting back now on genomics and NHGRI now over the last 3 decades, if we go back to that very beginning, what surprised you the most in terms of advances? What would you have just never in your wildest dreams predicted serving on that first advisory council 30 years ago? And you find where we are now.
I'm not sure I would have predicted that the cost of sequencing would be where it is today, where it is going to be part of medicine going forward, where it is now so cost effective that everyone will have at least the option of having their genome known. I don't think I would have predicted how critically important it was that genomics become a magnet for computer scientists, for physicists, for engineers, for chemists. But how exciting biology is now that we have them all as natural parts of our community. I think that's made everything more interesting and better. I think the surprises, I love surprises in science. I think that what's happening in cancer is just stunning. That we're thinking about cancer as a disease completely different than we were thinking about it before. I think the organization of the genome, which is something I've always been really interested in, how genomes are organized, how genes are organized to be properly regulated, just seems extraordinarily exciting to me. And I think, genome-wide association studies are now finally, after years and years of promise, looking as though they might be giving up some of their secrets.
Yeah, but looking at the genome sequence, yes, there's a tremendous amount we've learned, but going back to this idea of there'll be so much data and we won't know what it means, do you feel that, is it at all disappointing that we don't know more about the choreography of the genome, or you think we're this is exactly what one would have anticipated, it's just going to have to be patient and just take many, many years, which is typically what I say? Or has that it all been disappointing?
No, I don't think it's been disappointing at all. How many people sitting in this audience knew about RNAi?
Right.
Or knew about, long non-coding RNAs other than H19?
Right.
I think the genome keeps popping up surprises. I was just actually at a university in Japan where they are studying this hemichordate that has a genome of 70 million bases, and yet it has 22,000 genes. Right. I mean, what? That's another thing I would say that I think the Genome Project has completely unleashed is the ability to study in depth organisms
that you never would have.
That we would never have studied before. That, Jerry Fink used to call these the National Security Council, the 7 or 8 organisms for which there was good genetics, and the rest, 2 or 3 labs here and there might do something. Now, the world's our oyster, no pun intended.
Before we shift a little bit away from genomics, anything that worries you about the field, especially as it finds its way into medicine or as it's more broadly used for other purposes in society? Are there things that all this, you've seen a lot? Have you seen the molecular biology revolution arrive with some of its concerns? You've seen the early days of genomics.
So you're asking me at a very bad time because I'm in the midst of teaching a course at Princeton called Modern Genetics and Public Policy, and everything in this course worries me. Everything. This week we're on to genetic discrimination and privacy issues. We've talked about the complexity in the legal system of using DNA, which looked like it was going to be a panacea, and now it's not. I mean, there are a lot of huge public policy issues.
Do you think enough attention is being paid to those? As an institute that has an investment in bioethics research more than any other institute, but we're trying to tackle the hardest and most compelling problems. But the list keeps growing.
The list keeps growing. I
Right.
mean, we're now talking about germline genome editing. We were talking, Sid Mukherjee was talking about it a few minutes ago. I think the cost of gene therapy drugs is as one of these wonderful questioners here pointed out, is a serious issue. I can't imagine what it is like to sit in your seat every day or in Francis' seat and have, incoming, which must be happening on a daily basis.
Yeah, although I can't imagine presidency of Princeton's a cakewalk either. I'm sure there's different kinds of incoming.
Actually, it is a cakewalk.
Oh, I don't believe it. All right, so let's shift gears. I want to go back to that photo, which you led me right into about sort of the male-dominated nature of the community.
Yeah.
It was just so obvious. I mean, so you noticed it. One of the questions I was going to ask you is, did you notice this male domination? But clearly it was. You admitted that you thought you were recruited to mention some of these things because of 2X chromosomes. I would love to hear your view about how those issues have changed over 30 years. And I'm sure they haven't changed enough, but I'd be curious for you to give a bit of walk us through what you see as you've been such a champion for women in science. I'd be curious where you think we are, what we still need to do, and so forth.
So my sense of where we are today is that the slope is still positive, which is good from the 70s when I was coming up, but the value of that slope is becoming diminishingly small. We're not making a lot of progress right now. I think we are learning a lot more about why we're not seeing more progress. I think the advent of beginning to understand unconscious bias. The wonderful thing about having this new way of thinking about some of the barriers that women and underrepresented minorities face is we now have a clear and compelling evidence that it exists. We don't know what to do about it. I think that's really fair to say. And I know lots of places are working really hard with education and consciousness raising, but it's still not clear to me we know how to really deal with this. The other thing that we have all learned in painful ways is the degree to which sexual harassment, discrimination is still very much a part of the experience of too many women in the field.
And I assume you're familiar with all the things happening here at NIH, and
I am indeed.
And I assume you think this is the right trajectory.
Yep.
and are supportive. And I can tell you, last week we had a 2-day retreat of the institute directors, and Francis convened us, and we spent 2 to 3 hours talking about the very topic. More to follow coming up on things, advisory input coming in. But the problems, I mean, what I think is, and you just the problems just seem so hard, and the solutions not always obvious. Did you find I assume this was a key part of also your time as president. This must have been sort of in the priority list that you were trying to tackle at the time in a new position of leadership.
Yeah. In fact, one of the first things I did as president was ask Ginger Zakian, who many of you probably know in the audience, to chair a committee at Princeton to look across all disciplines. This was not just life sciences, it was across all disciplines, to see whether at Princeton there was evidence of the kinds of things that had been uncovered at MIT by Nancy Hopkins and her colleagues. And they produced, I think, the best report on that topic of any of the ones that I read across the universities who conducted them. And that became very much a road map for us about how we have to be vigilant. And this is an instance of eternal vigilance, where you have to pay attention, and you have to pay attention every year. You can't stop paying attention to things like salary discrimination, to things like space discrimination, startup discrimination, blah, 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 blah. You have to pay attention. And Ginger's report was absolutely critical in identifying the things that we needed to be paying attention to.
And it's the same for all underrepresented groups in science.
Absolutely.
You know, it's not just gender, it's every other dimension.
No.
Shifting slightly, I mean, to a different aspect of the scientific workforce, during your career you have been quite involved and quite thoughtful about different aspects of the scientific workforce. Are we training too many of this, too few of this? And so what has happened that has made you, that has pleased you, that you think has really moved the needle on some of the workforce issues, and what are some of the things that you still are critical, either that we are doing as a community or NIH is doing specifically?
Francis probably feels he hears from me too often on this topic.
We want to hear that.
But, so I think real progress has been made, actually, and I give Francis and I give the NIH a lot of credit for a lot of it. Everything from the importance of graduate programs and programs that train postdoctoral fellows in publishing on the web, where prospective graduate students go to look the career outcomes for their graduate students and their postdoctoral fellows over the last 15 years. This is something that has been recommended by every committee that's ever looked at workforce issues and has never happened, but now it's happening. And so it sounds like a little thing, but you know, that's how progress gets made, is you build on little things. Second, I think that Francis has used the Common Fund very effectively to identify beginning scientists who would otherwise be spending years and years and years and years writing grants about work that is just replicating what they did as a postdoc, and encouraging them through DP2s, through early career grants, to get out and to be proposing to do new and innovative things. And I think that's been a tremendous boon to young people who are just champing at the bit to get out and to be able to do really exciting new science. I wish there were more of them. I really wish there were more of them, because I think the pool of people who could take advantage of that kind of thing is much bigger than.
Although some individual institutes are doing things like this, including ours.
That's
and so
right.
There's some experiments going on across campus.
Yeah, GM, and I noticed that Tony Fauci is starting a program like this at AID. So I think it's really a very important thing.
What about the number of PhDs being trained? That's another thing I know you've taken a lot of interest in over the years.
I have taken a lot of interest, and when Bruce Alberts and Harold Varmus and Mark Kirshner and I wrote what we now horrifically describe as the most read paper any of us have ever written, called Rescuing Biomedical Research, we did propose basically birth control at the level of graduate admission. I think we have now been persuaded by our wiser colleagues that probably the better strategy is to encourage graduate students to be thinking about what they want to do with their careers and their PhDs when they are still graduate students. And the sort of the automatic, let's become a postdoc, no matter what I think I want to do eventually, I'll just go do a postdoc, is where the birth control should really start to happen. So, you know, those of us who believe that's the right place to sort of exert pressure on the system.
Of course, that's not done I mean, that's not quite like controlling a valve, right? It's a little harder because then you got to sort of get to the graduate programs and have abilities to be able to communicate that across the graduate student communities.
Yeah, but I'll tell you what was the most persuasive argument that I heard, which is, and it's been my experience at Princeton too, so I actually agreed with the argument. I'm not sure we're very good at all at predicting at the time of graduate admission who is really going to succeed. And if that's, I think we are much better once somebody has a graduate degree, we're much able.
So get them in and then guide them.
Right.
Yeah.
Yeah. So I think that argument persuaded me that we should probably focus on a slightly different pressure point. But you're right, it makes it harder.
So I have a couple more questions. I would please ask folks who want to ask Shirley questions, start queuing up at the microphones, and I hope people will, because I don't want to be the only one asking questions. While people are stampeding to the mics, let me, there'll be some bold folks, you'll see. Being a university president, did you at all aspire to that? Was that a total arm twist? Did you ever imagine when you started on faculty there that there would be a Tilghman walk or
So no. So in the way I ended up being elected by the trustees was I was asked to run for election to the search committee.
Oh,
So
that's a kiss of death sometimes.
People at this time have referred to this as my Dick Cheney moment, which I don't appreciate, by the way, at all. So I was the representative from the natural sciences on the search committee, and I frankly agreed to run and to join the committee because I had just founded the Genomics Institute, the Louis Sigler Institute, and I was desperate to make sure that the next president cared about genomics. That's all I really wanted, to be sure that I didn't get someone who didn't understand the importance of genomics. But about 6 months into the search, I was asked if I would leave the committee and become a candidate. And I, first of all, looked at them all and said, I can't leave you alone for a minute. You
turn back.
You make such bad decisions without me in the room. But then I was persuaded.
Did you enjoy it?
I adored it.
Yeah, because it seemed like you did.
I adored it. You know, the recession wasn't that much fun when the endowment dropped 23% in 3 months. But other than that, I loved the job. I learned so much about other disciplines. I learned what a hedge fund is.
That's how you got out of the recession?
Actually, that's a long story that I will not tell. But I loved it, but I also knew that 12 years was enough, and that I had done what I could, and it was time for somebody else to have a pair of fresh eyes to look at the university. Yeah. So I was very happy to go back to the Louis Sigler Institute and resume my faculty career.
Question.
Hi, my name is Babajide Oshela, and I'm a postback here. And you were speaking earlier about diversity, and I was wondering, could you explain what the benefit of having a more diverse community of scientists could bring to science and to genetics in specifics?
Why a more diverse community of scientists produces better science?
Yes.
And so, I really believe that. So I hopefully can explain to you why I believe it. I think there are ways of thinking, and I think there are problems to think about that do not happen if you have a community that is narrowly defined in any way, either in the way they're trained or in their socioeconomic background their geographical background, their gender, in all imaginable ways. So I think, and there's lots of evidence, actually, that comes out of business schools that shows that more diverse groups of people make better decisions. And I think it's because what you're getting, instead of the party line all the time, what you're getting are different perspectives and points of view. And that makes you stronger.
All right, thank you so much.
Over here.
I'm sensing a theme. So you seem to be very adamant about the inclusion quotient regarding organizations. And so in your experiences, have you found an organization that actually has kind of teed it up and done a few things right? And if so, what are those things that they did to actually generate the foundation for inclusion in their organizations?
When you're talking about rescuing biomedical research, that organization, or you're talking about the university? Which are you? I couldn't tell which organization you're referring to.
I'm talking generally in terms of organizations that might resemble the size and breadth of the NIH.
Yeah.
Essentially, it could be university, it could be another organization, it could be, generally I'm concerned about governmental organizations where, you know, we have policies and, you know, we're not a private business, we're open to the public and the public knows what we do and we report on it. So, you know, generally organizations like ours have statements that we make. We're a diverse and inclusive organization.
Yeah.
So in demonstrating that, I'm wondering if other organizations that you've seen, like this organization, perhaps a governmental organization, that has actually done a few things that you think are right to lay the foundation, and what might those be?
Yeah. I'll tell you a couple of things that I've learned with hard experience in this area. Number one, leadership matters. You will never make progress on diversifying an organization if the leadership is not fully on board. That's number one. Number two, it is much easier to do it if that leadership can exert a fair amount of influence across the entire institution. So let me give you my university version of this. If you look at institutions like Princeton, that have made, you know, a deep and profound commitment to this, we are doing really well at the undergraduate level. Why? Because undergraduate admission at the end of the day is all decided by one committee. And so if the leader cares about this issue and can go down to that committee and say, here's my priority for you, here's what I want you to accomplish, you can actually make huge progress and get it done. What happens at the graduate student level is graduate admission are done by 37 different committees that are in very different disciplines, everything from mathematics on the one hand to comp lit, comparative literature on the other hand. And it's much harder to get to those 37 committees and get them all on board with what your priority is. So when I think about an organization like the NIH, where, you know, you're like the distributed, right? You're the distributed kind of organization, because each one of the institute directors is pretty much, right?
Yeah.
Has
Damn straight.
and Francis, you know, is sitting there with moral suasion and the bully pulpit and a little bit of money in the common fund. Little, yes, he's pointing out little. Then the goal of really moving the whole place gets so much harder. And I know that just sounds like it's a really practical answer to your question, but it's my experience that solving the leadership and then solving how to deal with distributed systems of decision making is really critical.
Carolyn?
So I'm going to switch topics a little, and in a way I feel like Eric kind of jumped over a chunk of your career path, and as we think about the number of sort of trainees in the room, if you wanted to talk a little bit about sort of advice you have to people as they're making that switch from trainee to more independent investigator, or as someone who's in extramural into another career field, and also what were sort of the key things that you really feel like led to you having success at that stage in your career?
I often hate to answer the second part of that question, because one of the things that I'm really now persuaded of is that it is much harder today to be a young investigator than it was when I was moving up through the ranks. I mean, I was benefited from being in the golden age when biological research was expanding. There was room at all stages, at all career stages. Funding was generous. If you wrote a good grant, you got funded. Now it has to be, off scale sometimes to get funded. So I'm always nervous about sort of going and describing my own career path, because frankly I think it was much easier than it is today. My advice to young people when forced by them to offer it, one is look inside and ask yourself, is there fire in the belly for this work? Because I think because it's so challenging right now, if you don't have that fire in the belly, it's really hard to succeed in this particular climate. Do you love it? Do you get up in the morning and you just can't wait to get into the lab to see what happened overnight? I think that's very important. The second thing is start thinking as early as possible what you'd really like to do. And use your time in graduate school and as a postdoc to start exploring what those options are. Because it's too late at the end of a postdoc to start trying to figure out what it is you want to do. So start early and start planning. One of my most successful graduate students was a woman named Amy Hark, who came to me in her rotation and said, I want to work at a liberal arts college someday. And she planned her whole graduate and postdoc career around that goal, and today she's a full professor at Muhlenberg. She got exactly where she wanted to go. But I think that early planning really helped her. So I think early planning, and then recognize that there's lots of things you can do with a PhD. But you've got to know about them.
So I'm looking over here, some institute directors and NIH directors. Feel free to go to the microphone. We have another question. I have a question, but last call over here if anybody wants to ask a question. Allison.
From a non-institute director, aspiring institute director. I was just going to harken back a little bit to, you mentioned the Department of Energy and the beginnings of the Human Genome Project. And, when I first came here, I was surprised. I was like, DOE, what did they have to do with that? And from your perspective, what do you think was the most important thing that they offered to the equation and the guidance, and sort of how did they transition out of the involvement, and how did it become more NIH-centric?
So I think what DOE believed it had to offer was the ability to manage large technical projects, because that's what they have historically done. And I think they very much hoped that their role was going to be to develop technology, to beta test it, and then allow it to get out into the larger community. I think the way in which the decision ultimately was made to have NIH be the primary leader of the Genome Project was frankly a turf war that NIH won. I think the NIH could not imagine allowing the human genome to be sequenced only in the Department of Energy. There were all kinds of good reasons why they believed that would not have been a good outcome. I actually believe it would not have been a good outcome too. But I think at the end of the day, there was a reasonable partnership between DOE and NIH that was challenging to manage, to be sure, but I think at the end of the day, both made contributions to the success of the project. Thank you.
Dr. Collins.
Shirley, it's great to have you here and to hear your wise reflections on the last 30 plus years. And I have to tell you how much I personally have benefited from your wise advice, going back to that interview when you convinced me it was worth considering becoming a federal employee, and I'm still here. That would have been, I think, the fall of 1992. It's been quite a while. And I also remember some other times when, as a really important, wise part of the advisory council to the Genome Center, which then became the Genome Institute, I knew I could count on you to sort of step aside from all of the sort of nitpicky things that people got hung up on and advise in a way that brought everybody else along. What's the big picture here and what's the right thing to do? I think you even helped me one time convincing one of our major genome leaders who was getting ready to bail to stay in his current position, which has turned out well for everybody. I'm talking about Eric Lander.
That is called pastoral care.
Yeah, you did it well. But I guess you are now part of this rescuing biomedical research effort, and you and I have talked about that on numerous occasions, and you and your group of very senior, very experienced, let's not say totally emeritus, but some of them are, advisors have continued to provide serious advice about what we should do with the overall status of medical research. What's the current plan for the RBR group? What are you focused on right now? What are the things that we NIH ought to be sure we're paying more attention to? I'll give you the opportunity to hit me with it.
Well, one of them I think you will embrace, which is we want to be sure that there is the next generation of leaders in biomedical science thinking about these issues and leading, helping to lead the community. So the way I put it, who is the next Bruce Alberts? Who is the next Harold Varmus? Who are the people coming up now who should be assuming these roles, and not just, frankly, with RBR, although we're cultivating them like crazy. But, biomedical research has benefited from having people of your quality and Harold's and Bruce's qualities and Eric's quality to agree that public service is a noble undertaking, yes, and that you give up an enormous amount by coming into government service. And I know this is a hard ask at the moment, but it's critical. The NIH needs great leadership. The NAS needs great leadership, on and on and on. And so one of our things we're focused on now is replacing ourselves, which is really important. And another thing that we are focused in on, and again, this is not an NIH issue, but let me just tell you, is that we are working with Howard Hughes and with Dora on better ways to evaluate faculty. And this comes out of the horrors of using horrible metrics to decide whether somebody is meritorious or not. But it's a broader issue. It's a broader issue about how do we evaluate science? How do we do it? What are the best ways to do it? It will have an impact, hopefully, at some point on the way we review grants. But we're also focused on how universities hire and how they promote, yeah, and whether they are using the right set of values in order to promote really good people. The third rail, are you ready for a third rail one?
Bring it on. We
think the NIH should stop paying 100% of salaries of people in the extramural society. We would like to see you eventually get to a cap of something like 50% of salary, because we think too much of NIH dollars are going to allow universities to infinitely expand.
The faint scream you just heard was from the Scripps Institute, but keep going.
And
And you think universities will step up and not push back too hard?
Oh, I think this is the third rail.
Right.
You know, I've had conversations with some of your peers who will go unmentioned here at the NIH who believe that this is right, but who are having a really hard time seeing any path forward. Because it's not just Scripps, it's the universities, it's the academic medical centers. This is a hard one, but I think at the end of the day, there are all kinds of perverse incentives here with salary that I think have led to a lot of the hyper competition that at the bottom worries us the most. So if you have any insights into this, Francis, I realize you have other fish to fry at the moment, but I think that's a big one.
I agree it's a big one, and I hope everybody in this auditorium has just now heard why it is that I said earlier that Shirley Tilghman has always been the person who has the big picture and has figured out where the most important steps are that we need to take in order to enrich and encourage this remarkable workforce in biomedicine that we're all so fortunate to be able to work with. Thank you, Shirley.
So, one last question. So we've focused on the last 30 years. I want to hear about the next 30 years. So what do you have planned next? You've obviously transitioned back. You're teaching public policy and science. You're doing all sorts of other things. But I don't get the sense that you've done your last hurrah.
So I have a 2020 project that I'll tell you about. So I am now working for a organization that Michelle Obama founded when she left the White House called When We All Vote. And it is focused on getting college students registered and voting and underrepresented minorities registered and voting.
This is a national effort?
Yeah.
Okay.
So this is a very small organization run by people who came out of the domestic side of the White House. But we've joined forces with a bunch of other organizations that are working on voter registration, voter suppression, and that's what I'll be doing full time for 2020, is trying to get this country voting. Woo! Of course, bothering Francis from time to time.
Of course. Shirley, you did not disappoint at all. This was absolutely fabulous. Thank you so much for coming, sharing your thoughts, your wisdom, and your advice, and you're such a great friend of all of ours. Thank you so much. Give you two gifts. Maybe here, come get a picture. What? Oh, sure. Francis, can you come up here real quick? We'll take one more. And people don't leave because we're going to then do the annual institute-wide photo. So lock the doors. Well,